on hot mic. Hey, Adeline. We're going to start with a review. In the textbook, it's called Just in Time. We're not hitting every single one of them. We're going to hit the ones that you should know, or you may not remember, or are going to come up later with some harder skills. The first thing we're going to hit is the family tree of numbers. There's a desk right here. Are you good? The family tree of numbers is where we're going to break down the names for the specific number families, and it is really important that you know them because it's going to come up, especially the notation. Notation means the symbol. So the first broadest question for the number family is it real or imaginary? That's the first place that numbers break off into categories. It's either a real number or it's an imaginary number. Okay? So, family tree of numbers, you have real. Notice how I'm going to write the word real. Actually, let me make it stand out. You have the real numbers versus the imaginary numbers. Actually, and I will color coordinate that too. Let's do this. You're going to see why. You may already know why. You got real versus imaginary. The green little first letter is the notation for it. So it's kind of like almost looks like a fancy block R, and then you have the lowercase cursive I, technically cursive, I guess you could say, italicized, let's say that, italicized I. So the little block capital R is the notation for the real family, and the lowercase italicized I is the notation for the imaginary family. You don't have an imaginary number unless you have taken the square root of a negative number. That's when the imaginary numbers came in, and we'll refresh your memory on that on another day. Today, I just want to do a couple of basics. We are not going to talk about imaginary right now. We're going to talk about the real, okay? So I'm going to draw a diagram. Let's see, I got to space it out right. Give me a second to write this and draw it to make sure it's going to fit before you copy it down. So we've got the reals. Let's see, I need to grab it all. See, if I don't make enough room, I can do a magic trick. And now it fits. Okay, so you don't have to draw the whole thing. You can draw it as we're going. I'm going to start right here. Real numbers. Real numbers splits into two categories. You have irrational or rational. Irrational or rational. The notation for real, we already addressed this. I'm going to put it in little squigglies. Is like drawing two parallel lines and then you connect the back one to the front one to create that R. It's like drawing two parallel lines, connect that back one to the front one to create the R. Imaginary means you have taken the square root of the negative number. You've now crossed into la-la land. You are now in numbers that don't exist. Real means you're dealing with numbers that do exist, which is why it's called real numbers. Mathematicians were not very creative, or you could say they actually really were creative. I don't know, you could argue it either way. But mathematicians named things to give you clues as to what the meaning of it is or what it is that it got named. Real numbers are 1/2, 2.3, -10, 12, 6,243.8912. I don't know, make them up. It's any number at all that exists as long as it has no I in it to indicate that it's an imaginary number. Real numbers can be found on the number line, even if it's a decimal. Okay, so real numbers break apart into two categories. You have irrational and rational. Think of it as there's two types of people in the world. There's irrational people or there's rational people. Irrational people, or numbers, if you think about it, irrational people cannot be dealt with, right? You can't even deal with them. You can't reason with them. You just got to let them throw the little fit and then, smile and wave and then walk on. Irrational numbers are kind of the same way in that you cannot deal with them. They cannot be written as starts with an F, it's not 4 letters. They cannot be written as a fraction. That is an irrational number. Okay, so the square root of 3. The square root of 3 is irrational because there's no way to write it as a fraction. The square root of 4, well, that's 2. That can be written as a fraction, 2/1. So irrational numbers cannot be written as a fraction, which means rational numbers can be written as a fraction. So like the decimal 0.33333 repeated, that can be written as a fraction. That's 1/3. So that would be considered a rational number. There is a notation for rational, and it is self-explanatory. You might think at first, good grief, why is it a Q? It's a Q for the fancy fraction word. Yes, quotient. Quotient, if you remember, means fraction. It's a division of two numbers. So Q is the notation for the rational number system, and it's because of the word quotient. Now, y'all are doing really good at whatever I write, you write. If you need to fill in extra, like if you want to put quotient right there, you can. It's Quotient. So we're going to talk about the rational numbers now, which means the numbers that can be written as fractions. If I focus on the rational numbers, I now have two categories of numbers. I have, this one's fancy, not integers, or non-integers would probably be more correct. Non-integers, and then integers. Okay, the integer family has a notation. It is like a Z, capital Z, but there is a bar in the middle to show you're not actually talking about the letter Z, you're talking about the family number of integers. Now, why is it Z? I don't know. But it is. Okay, so what are integers? We're going to do an example underneath. I kind of meant for there to be a little space right here. And I'm going to write a little smaller. Okay, so we're dealing with real numbers. Then we're dealing with numbers that can be written as fractions. Not necessarily has to be a fraction at first. It's just a number that could be a fraction, like a whole number, 2. That could be a fraction, 2/1. Then we're going to break it apart into non-integers and integers. The integers are the nice numbers that you would label on a number line. They're the nice numbers that you would label on a number line. So if I gave you a number line and I said label this, instinctively you probably put nice pretty numbers. And those are the integers. Notice it includes both negatives and positives and the number 0 in the middle. So integers are the numbers that in order to write them as a fraction, you have to indicate the understood 1 that's on the bottom. Those are the integer family. So if I said, you know, how is this a fraction? You would come underneath it and say, because there's an understood 1 right there. Now it's a fraction. That's the integer family. Non-integers are numbers that are straight up fractions. 2/3, 1/3, 4/5. Any given fraction is a non-integer. So now focusing on the integer family. So now focus your attention on the nice pretty numbers. We're going to break them into 2 categories. That would be the negative numbers. The negative side were negative integers. I guess I shouldn't put numbers because that might imply other numbers. Let's say negative integers. So you got the negative ones. Those are Beyonce's favorite. Do you know why? This is so stupid. Because they're where? They're to the left. Yeah. Those are her favorite. I'm not even that big of a Beyonce fan, but I love playing that to the left joke on anything that it comes up. Not that I don't like her, I don't get excited when her album drops or anything. I'll just hear it on the radio. So you got the negative integers, which means you have then the positive integers, okay, which are called whole numbers. So the positive integers are the whole numbers that we're going to address. I'm going to put whole numbers in parentheses right here. That's the technical name for it, but to help you, it is the positive integers. So that would include 0, 1, 2, 3, and on. So it starts at 0, 1, 2, 3, and so forth. There's no notation for whole numbers. There's no fancy symbol. The only symbols that you need to know are real numbers, which should be self-explanatory. Rational numbers, which now that I've told you quotient should help, quotient fraction. Integers, it's just the one left. And then imaginary should be self-explanatory. I. Positive whole numbers. So starts at 0, counts up. If we're focusing on just the numbers 0, 1, 2, 3, now I can break that into two categories. One category has a number by itself, the number 0. The other category is what we call the natural numbers, which means this starts with the number 1 and counts up. The natural numbers do have a notation for them, and it's self-explanatory. It is a capital N. You do put a bar across the middle, kind of like you did with the Z. You just kind of make that middle, that looks terrible, but you make that middle part of the capital N kind of like a bar, and that's the notation for natural numbers. Now, how are you going to remember this? I'm going to show you a stupid way. Stupid as in corny. You're welcome. If I tell you to count something, what is the natural way to start counting? 1. Okay, so the natural numbers start at 1. And then the whole numbers, this is where it gets a little cheesy. I'm going to use red. I hate red, but I'm going to use red to make it stand out. The whole numbers start at 0. So that's how I remember natural numbers start at 1, because that's the natural way to count. Whole numbers start at 0. Whole, like, and you can even think of, like, there's a hole at the beginning of this set of numbers if you wanted to think of it that way. So, number families. We will practice with recognizing if a number is in a certain family, and it can be in more than one family. You're definitely going to see those green notations come up a lot, especially, well, all of them. All of them are going to come up, especially when we start naming sets. Okay, so the next review that I want to do, and then we're done for the day. Everybody good with this screen? So I change. You learned at one point the number families. It may not have been laid out to you like that with the family tree and showing you the breakdown, but at some point, and it might have been told to you in casual conversation.
Can I please get Mariana Polina to the front office for this report?
She's on her way.
Thank you.
It was probably brought up in casual conversation while your teacher was teaching or something, which meant maybe it wasn't as important then, but it is now. So if it's something you either don't remember or you think you didn't, weren't taught, just, look at it and study it so that you know it moving forward. Because when we do sets, which will be tomorrow, you need to know the breakdown. And it's okay to reference this, to come back to it, to look at it. Okay, so the next thing, I'm going to just write, actually I'm probably going to type it. I'm going to type this, and you just copy it down and then answer it. It is just your basic sign rules. adding, subtracting, multiplying with positive and negative numbers. Just a real quick refresher, do you remember the sign rules? So this would be titled Just-in-Time Review number 5. Oh my gosh, I'm sorry. I just stepped on his foot. Sorry. This is Just-in-Time Review number 5. Like I said, we're not hitting every just-in-time review. I'm only going to the ones that matter. The one we just did, I think, was number 1. Sign rules. Okay, so there's your first 3. You can take a picture if you want when I'm done. It's up to you. There's subtract. Oh my. Oh no, how do I get the divide? If I do this, do y'all know that that's divide? Okay. And this is the last one. All right, I'm going to shift them so you can see better. And I'm going to get the fancy divide symbol, because that bothers me. Let's see, it's right here. This is probably going to block it. Hold on one second. There we go. There we go. The bell rings in 2 minutes. If you want, you can take a picture of that and copy it later, or you can, I'm going to save it. I can pop it up there to get into class tomorrow. But I would like you to come back with those answered, or when you get in here first thing in the morning, answer them. Don't answer them with your calculator if you can avoid it. Try to answer it without it. You can go in and check it with your calculator. Remember, report to Flex for attendance, and then you're going to the auditorium for your pep rally, and I have a feeling there is a dance-off. Yes. That's 12 graders. 11 graders, y'all's pep rally is tomorrow, and I'll look at the email and tell you which lunch to go to the theater. Remind me tomorrow.